the first principle of quantum number. So now if I want the 4 quantum number for the boron, if I put the 4, so I need to deal with the last energy level of 2p. So the main quantum number, not to go to 1s2 or 2s2, no, the last electron in the last orbital, in the higher orbital shell. So this electron can take, so I have to draw the shape of p orbital. So the p orbital consists of 3 suborbitals. This is 2p. So here we have to put the electron to the left side here. And this electron, if I want to put the data on this orbital, I have to put the orbital. I can put 0 here in the middle, -1 to the right, +1 to the left. And here, this is called the ML, the magnetic orbital quantum number. Okay, now if I come to the first quantum number, the main one, the principal one, is n. So what is the n, the last orbital is 2p1. So when you see the 2 here, this is the n number. Okay, if I want to take the second quantum number, which is L orbital, so the orbital here I have is a p. So what is the number for the p? As we said, p can take number 1 because s is 0. The third quantum number is the magnetic orbital quantum number, ml. So the ml should be where the electron occupied the orbital. I can take the number above it, will be +1. And now I come to the spin, magnetic spin quantum number s. So the magnetic spin will go to where is standing clockwise, so the spin is +½ So these are the 4 quantum numbers describe the property of boron. Okay, so if I take another example, quantum number for, let's say, if I've been given 4 quantum numbers, now we come to another question. If you've been given 4 quantum numbers, so you need to identify the atomic number and the element name. So the 4 quantum numbers, if being given n4, L is 0, MS, okay, ML 0, and MS -½ Let's take this example. So if you have the n is 4, it means I put 4 to the left. This is the, so it should be 4, we ending with the orbital in the main shell 4. So I have to put all the orbitals before the 4. Now I come to the L. L is the name of the orbital. So if the L is 0, so what is the orbital type? So L0, it means S. So if in S, the ML should be 0, and that's right, the ML. The spin is -½ So if the spin -½ so this orbital, this orbital of s should be occupied by the second electron. So if there is a second orbital, should be the first orbital is there as well. So I have to estimate wherever, if I have half n plus, the spin half n plus, I shouldn't draw the second electron. But because I have a half spin, it means the electron is on anti-clockwise spinning and should be accompanied by another one before it. So as we said, we have to write all the numbers. So the last electrons will be 2 of them. So if I have 4s2, so I have to put all the orbitals before 4s2. So I start with 1s2 should be fully occupied, 2s2 as well, 2p6, 3s2, 3p6, and the last one will come 4s2. I stop here. So as we said, because 4s2 is the lower energy level, so I should, or not should, but sometimes we need to indicate the 3D as well. So after 4s will come 3D, but there is nothing in it. We put 0.